On today's episode, robot tractors hit the field, and will Sony be the next major EV manufacturer? Today's episode is brought to you by Engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on Engineering.com TV today. For decades, Tokyo-based consumer electronics giant Sony Corporation has been a manufacturer of consumer electronics, starting with the first widely produced transistor radios in the late 1950s. The company has grown to include multiple divisions operating in areas as broad as electronic materials and movie production. But at the 2022 Consumer Electronics Show in Las Vegas, the company unveiled a prototype of a new product in an industry with which Sony has never been associated: cars. At the 2020 CES, Sony announced an initiative the company called Vision S, exhibiting a prototype at their booth and following up with road testing in Europe. As expected, Sony is focused on imaging and sensing technology and the user experience, and the company began 5G testing of the car in April of last year. At this year's show, Sony unveiled a crossover SUV prototype to join the sedan, sharing the same platform and cloud connectivity of the earlier sedan. The new prototype, at this point called the Vision S02, is a 7-seater which the company declares will accommodate a large variety of lifestyles within a society whose values are becoming increasingly diversified. Now, in engineering terms, this means a sensor suite of high-resolution CMOS image sensors and LiDAR integrated with the vehicle's entertainment system and driver displays, alerting the driver to obstacles in unsafe driving conditions. In current development, Sony declares that the systems will be released at Level 2+, according to the SAE Autonomous Driving Ranking System, similar to Tesla and most other manufacturers. One difference to conventional driver assist systems is Sony's emphasis on low-latency 5G cloud connectivity to allow remote operation. Experimentally, the company has connected vehicles between Japan and Germany with low-latency systems using the company's knowledge base in handheld devices. Vehicle settings, locks, and over-the-air software updates are expected to be handled through the cloud, although the company has not specified if these will be software-as-a-service offerings. Perhaps the biggest difference between Sony's EV intentions and those of legacy auto and EV startups is their plan to use the vehicles as a delivery system for immersive music experiences, high-definition digital video services, and gaming using the company's PlayStation platform. Now, to turn this ambitious project into reality, the firm has launched a new company, Sony Mobility Inc. So if you've been wondering what drivers will do with their time once self-driving vehicles take over, Sony intends to keep them well entertained. If you like this show, be sure to subscribe to our channel and click on the notification bell for our next episode. Fully autonomous driving has been the most anticipated consumer technology of the last 10 years, and it's close enough that companies like Cruise, Waymo, Argo AI, and TuSimple are operating autonomous vehicles on public streets today. But cab drivers and truckers are not the only people that spend long hours behind the wheel. Farmers spend much of their working life behind the wheel, doing monotonous but essential operations in things like tillage, seeding, dressing, and harvesting. Now, self-driving tractors have been talked about for years, but strictly as prototypes. This is changing, and at the Consumer Electronics Show 2022, Moline, Illinois-based John Deere announced the company's first tractor that can be optionally operated autonomously or by a human. The engineering challenges are similar to those in auto self-driving systems. While obstacle detection is a common problem, there are differences in the way tractors operate in the fields compared to motor vehicles on roads. A major debate about the way forward in self-driving is the way sensory data is aggregated and processed. Now, Tesla uses cameras and an algorithm to make sense of the images, while other companies use combinations of LiDAR and other sensors to detect obstacles, in combination with predefined area mapping. The John Deere system uses 6 pairs of stereo cameras whose images are passed through a deep neural network that classifies each pixel in approximately 100 milliseconds, and then determines if the machine continues to move or stops, depending on obstacle detection. While this is similar to Tesla's approach, the Deere system also uses position checking relative to a geofence, accurate to a resolution of less than an inch. Farmers must drive the tractor to the field, then turn on the autonomous function, which they can then monitor anywhere from a mobile device. The operating app feeds the farmer real-time data, including video feeds, essential speed and depth information, as well as the running performance of the tractor. What makes the John Deere system different from other autonomous tractor experiments? Well, the main difference is that the John Deere system will be available for order later this year and is based on existing 8R tractor and implement technology and can be operated like a conventional machine in non-geofenced areas. With serious labor disruptions and a chronic labor shortage in the agriculture sector, robotic tractor technology couldn't come at a better time. Well, that's it for today's episode of This Week in Engineering, brought to you by engineering.com. For our Deeper Engineering series, visit engineering.com TV for exclusive shows like Manufacturing the Future and Designing the Future, not found on our YouTube channel. The links are in the description below. Thanks for watching.